Yes, good afternoon to everyone. I welcome you all for the lab session, today's lab session. Okay, in today's lab, we are going to do the experiment number 4. Okay, so it is multiplication of two 8-bit data. Fine. So the aim of the particular experiment is to develop an 8085 ALP and to test its operation. Okay, so consider this problem statement. Okay, two 8-bit data x and y. Okay, x we call it as multiplicand, the first operand, and y we call it as multiplier, the second operand, available in the memory address 9000H and 9001 respectively. Fine. So what we have to do? Find the product of x and y. Okay, both should be multiplied, and the result must be stored in memory address 9500 and 9501 respectively. Okay. Lower byte must get stored in 9500 and higher byte must get stored in 9501. Fine. Obviously, when we are multiplying two 8-bit data, the result will exceed. The result may exceed 8-bit. Okay. So the result. So we are splitting the result into 2 bytes, lower byte and higher byte. Fine. So kindly take a screenshot of this. Let me have some prerequisite questions. Yes, shall we proceed? Yes, okay, fine. So how the multiplication operation can be done in 8085 microprocessor? Okay, first can you people type it in the chat? What are the different arithmetic operation 8085 can do? 8085 enna arithmetic operation la possible? Kindly type it in the chat. Yes, addition, very good. Subtraction, then addition, subtraction, where only Dhanya is typed in the first classroom. What about the others? Yes, increment, decrement, 16-bit binary addition, very good. Then that's what Logus Nega is also typing, double addition, very good. Then that and all logical operation, Anthony Surya, I am asking about arithmetic operations. Whether we have multiplication operation, whether we had any instruction to perform multiplication operation, no. So what we are going to do in 8085, how we can do multiplication operation? Any idea? See, multiplication means what? Say for example, 5 4s are 20, correct? How I am pronouncing? Yes, very good Dhanya. Very good Anthony Surya. Using addition we can perform, repeated addition, very good. By performing a repeated addition, we can do multiplication in 8085 microprocessor. Okay. In advanced processor, that means the next version 8086, there and all you have a specific instruction. Even in 8051 microcontroller, we have an instruction to perform multiplication. Okay, but in the case of 8085, we have to do a repeated addition to perform multiplication. Okay, so repeated addition by considering multiplicand as data and multiplier as a count value. Multiplicand data va consider panikrom, multiplier count value assume panikrom. Fine, we have to add the data again and again till the count expires, count value gets 0. Fine. So that is the logic we are going to use here. So what are the essential things we have to initialize in this program? Enna initialize pannumpa? Repeated addition must start. Very good. Count value. Then what about other things? So we have to initialize the multiplicand and the multiplier. Multiplicand or general purpose register lo vechikalam. Multiplier we can keep it in another general purpose register. Okay. What about the initial value in accumulator? When we are starting the repeated addition, what about the initial sum? Initial value enna irukkum accumulator. Yes, very good, very good, very good. Similarly, whenever we are adding, okay, we might get carry. So at that time, what we have to do? Just consider the block of addition program. There what we did. Accumulator value 0. Okay, fine. So initial sum on the 0. Yes. So we can clear accumulator. Okay, we can use ADC, but again the result will be what happened? See, நீங்க repeated addition பண்ணாலும் அதில் நமக்கு என்ன சொல்றது? When we are getting carry, okay, your result will be always 8-bit in accumulator, correct? For example, when I am adding 99 plus 99, we will be getting carry, correct? So 98 as sum and 1 as carry. When you do ADC, the carry will get added with the repeated addition. Okay, it won't help us to increment the higher digits. So for that, what we have to do? You just refer the block of addition program, addition of block of data program. Whenever carry occurs during the repeated addition, we have to keep on incrementing one register. That is going to consider as a higher byte of the result. Do you remember? Yes. Yes, very good, Shivakumar. Store it in another register. Okay. Whenever carry occurs, we have to use some other register. Okay. It will increment whenever carry occurs. So it will be considered as higher byte of your result. Fine. Okay. So clear accumulator register, clear a general purpose register to accumulate carry. So the meaning for to accumulate carry is whenever carry occurs during the repeated addition, we have to increment the general purpose register by 1, so that your higher byte of the result will be getting accumulated in the that particular register. That's all. Okay, fine. So first thing, we have to get the multiplicand, get the multiplier to general purpose register. Then we have to clear accumulator in any one of the general purpose register. Fine. Okay. What about the first instruction we will use in this particular program? The data are available in 9000H and 9001H. Here, for example, I consider 75H and 04H. Okay. So these are the two inputs I am considering for explaining this program. Okay. So what about the first instruction? We have to get this data 75 to CPU. Correct? So for that, what we have to do? What about the first instruction? Yes, very good, Sajesh. Anthony Surya, the data must be taken from 9000H. Kindly check it. What you have typed is the instruction is correct, but the address is different. Okay, kindly correct it. LDA 9000. Fine. So the very first instruction is LDA 9000H. So after executing this particular instruction, accumulator is getting 75. Okay. Now to take the multiplier, from the memory location 9001, what we have to do? Again, which instruction we have to use? Again, which instruction we have to use? Yes, very good. LDA 9001 we have to use. But before getting the data, the multiplier to the accumulator, okay, we have to move the data currently present in accumulator to some other register. So what we can do? Move B, A. Fine. So the data in accumulator is copied to B register also. Now A and B are having the value 75 and 75. Fine. Now we can take the second data, that is the multiplier. Fine. So LDA 9001. So after executing this particular instruction, accumulator is having 04. Okay. We are going to perform repeated addition. Correct. So we need to clear the accumulator initially, so that the initial sum must be 0. Fine. So we have to move this value 04 to some other register. So we are moving to C register. Okay. So now multiplicand is present in which register? The multiplier where it is available. Multiplicand enga irukku, multiplier enga irukku. Before that, we need to do two more steps. Clear the accumulator. So for that, I am using the instruction XRA A. So accumulator content got clear. Fine. Also, we have cleared one general purpose register to accumulate the carry. Fine. So I am using D register. See, MVI D,00 also we can write, or else move D, A. Already accumulator is having 0 only. So D register content is also 0. Fine. Now we are going to use 3 registers here. B holding the data, that is the multiplicand, and the C register is holding the count, that is the multiplier. Fine. The initial sum in accumulator is 0. Fine. To store the carry, to accumulate the carry, we use D register. This 4 register we are using now. Fine. Now we can start the repeated addition process. Fine. Shall we perform the repeated addition? Yes. Okay. Okay. Which one we consider as multiplier? In which register the multiplier value is stored? Yes, C register. It is considered as count now. So, count. What about the value present in B register? It's a multiplicand that we are going to call it as data. Yes. So, the data one I na again and again accumulator kuda add pannite varum. Clear? Till the count got 0. The count in C register got 0. Fine. Shall we proceed? Up to this program purinjada? Yes. Okay, fine. Now, add the multiplicand with the content of accumulator. So, which instruction we have to use? Any instruction use for here? Multiplicand, that is data. Data enga irukku? Where is the data now? Multiplicand is data and so correct? Add C means you are adding the count value with accumulator. Fine. So, you have to fix it. Multiplier count or else multiplicand count. Fine. You can take either one thing as a count and another thing as a data. Generally, multiplier we consider it as count. Okay. So add D. Very good. Add D. Yes, add B is the correct instruction. Add B is the correct instruction. Very good. So add B. So what will happen? 75 get added with 0, 0. So what about the accumulator content after executing the instruction? Can you people type it in the chat? Add B. What about the result? Yes, very good. 75H. 75H. Fine. Now, whether we got carry during this addition operation? Whether we got carry during this addition operation, check the flag. No. So, is carry irunda enna pannum next instruction poganum carry illana enga poganum it has to skip that. So J and C skip, like that we are mentioning. J and C skip. Carry illana enga varanum it has to decrement the count value. Correct? Fine. So the next instruction must be DCRC. Okay, so DCRC, the count value get decrement by 1. So initial count 4 potundo. So after executing this instruction, the count become 3. Correct? Now you check whether the count is over. How we will check? When I am decrementing, when the count becomes 0, it indicates the repeated addition can be terminated. Fine. Now we have to check for 0 flag. Jump no 0 to the repeated addition. J and Z to next. So here it comes. So repeatedly this operation is going to take place. Correct? Yes. Okay. When carry occurs, what we have to do? When carry occurs, shall we go? Okay. Next loop. So second time nama addition panone 75 plus 75 EA is the result. Correct? Now also no carry. So we are decrementing the count. Okay. So the count got decremented. So now also 0 flag is reset. So J in set is true condition. So it is moving to the repeated addition. Okay. Now during this addition, I got carry. Correct? You can see here. Now I got carry. Previously, I got EA kuda add on 75. Fine. See, that's why the name accumulator. When we are doing the repeated addition, the sum value is getting accumulated in the register A. Correct? Fine. So after executing add B, it becomes 5F carry occur. If carry occur, what we have to do? J and C skip. So this instruction will come where the program has to go. Whether it has to go to DCRC instruction. So carry occur. correct? So carry illana da enga poganum, it has to go to DCRC instruction directly, correct? So now what it has to do, what we have to do, which register we have used to accumulate the carry. Whenever carry happens, okay, yes, very good Logas Nega, very good Anthony Surya, Danya, very good. Yes, we have to use INR D, very good. Fine, we have to increment the D register content, then it keep on doing the as usual routine. DCRC, now count is non-zero. So again, we have to perform the addition. So now, after addition, the result is D4, okay. There is no carry now also, fine. So it skip the INR D instruction, directly it move to where? Skip the JNC instruction, okay. So it is going to DCRC. So count got decremented. Okay. I think here one mistake happened in the animation. Okay. So in the DCRC, 8010 has to come. There is some mistake happened in the animation. Okay. Kindly correct it. So 800F 8010 has to come. Okay. So zero flag set ஆயிடுச்சு நமக்கு. Yes, zero flag set ஆனதுனால நமக்கு என்னது? After executing this JNZ instruction, it won't goes to 800A memory location. Why? In the instruction execute ஆயிடுச்சுப்பா. இது DCRC execute ஆயிடுச்சு. Correct? So previous count enter இருந்துச்சு பாருங்க 1. So now it becomes 0. Okay, zero flag set ஆயிடுச்சு. So JNZ next அப்படினு போட்டுருக்கோம். Fine. Now zero flag is set. That means this condition get false. So அப்ப நம்ம கொடுத்திருக்க அட்ரஸ்க்கு போகாது, லேபிள் அட்ரஸ்க்கு போகாது. It will skip the JNZ instruction. Fine. So the current instruction is available in 8010. So it is a 3-byte instruction. JNZ output 1 byte. The address, it takes 2 byte. So the next instruction will be in 8013. That's why we are having 8013 here. Fine. Fine. So here we have the instruction STA9500. Okay. Now you people tell me where the lower byte of the result is available and higher byte of the result is available. When I am doing repeated addition, lower byte of the result will be always in which register? The repeated addition we pandrom illaya. After performing every addition, where the result is getting stored? Yes, Sajish typed in the second classroom. What about in classroom 1? Lower byte in accumulated. Very good. What about higher byte? Anthony Surya, I think you have got confused with the instruction. Okay, I'm asking the question where the lower byte and higher byte of the result gets stored after execution of previous instruction. So in the instruction முடிய நமக்கு result எங்க இருக்கு பாருங்க. Lower byte of the result எங்க accumulate ஆயிருக்கு? It is available in accumulator register. Where the higher byte of the result available? Yes, Shivakumar, higher byte is available in D register, correct? So don't forget this. Yes. So STA 9500 means what? Lower byte of the result is going to stored in 9500. D4 poi store aiduchi. Fine. Next, the higher byte of the result has to be stored in 9501. For this, what we have to do? For this, what we have to do? Higher byte of the result D register la irukku, ana memory la poi store pannom. What we have to do? Yes, Sajish typed the answer in second classroom. Yes, very good Sajish. What about in classroom 1? Higher byte of the result வந்து D register la irukku, ada memory la poi store பண்ணனும்னா first என்ன பண்ணனும்? What we have to do first? Danya, kindly check move D, A. Yes, lovely, very good. Move A, D is the correct thing. Fine. Move A, D. D register la the higher byte value na enna panniyachu, accumulate la potachi. Now it has to be stored in 9501. So what instruction we have to use? Which instruction we have to use to store the higher byte in 9501? Yes, very good. STA 9501. STA 9501. Very good. Fine. So after executing the instruction, the higher byte got stored in 9501. Fine. So So finally, obviously we have to use halt instruction to stop the program execution. Is it clear to all of you? Is it clear to all of you? Is the program is clear? Yes. So what we are doing, multiplicand, we considering it as a data, keeping in one register. Multiplier as count, we are keeping it in some other register. Okay. Initial sum has to be 0. So accumulator content we are clearing. Fine. Similarly, we are using one more register to accumulate the carry. Whenever carry occurs, that particular register should be incremented. Fine. So after initializing this thing, add data with accumulator. If carry comes, increment that register or else decrement the count. If no 0, continue this process till the count becomes 0. That's all. So that's the logic we have used here. I hope it is clear for everyone. Yes. What about in second classroom? See, I think I am handling class only for Sajis. Nobody is responding in the second classroom except very few. Abhinesh answer பண்ணுவாரு, கார்த்திகேயன் பண்ணுவாரு, சஜீஷ் பண்ணுவாரு. கரெக்டா? எப்பயாவது ஷாலினி பண்ணுவாங்க, அவ்வளவுதான். வேற யாரும் இந்த கிளாஸ்ல ஆன்சரே பண்றது கிடையாது. அதே மாதிரி கிளாஸ் ரூம் 1 எடுத்துக்கிட்டோம்னா ரிப்பீட்டட் நேம்ஸ் தான். கரெக்டா? See, this is a online environment. உங்களோட மூஞ்சி நாங்க பார்க்க முடியாது. கரெக்டா? சோ உனக்கு தெரிஞ்சிருக்கா இல்லையான்றதெல்லாம் we can't imagine. Clear? If you say yes, okay, உங்களுக்கு புரிஞ்சிருக்குன்னு நான் எடுத்துக்கலாம். அதர்வைஸ் ரெண்டு விஷயம் எடுத்துக்கலாம். ஒன்னு புரியலன்னு எடுத்துக்கலாம். The other thing, நீ கிளாஸே கவனிக்கலன்னு தான் எடுத்துக்கலாம். See, don't do like this. Kindly interact. Afternoon session, lab session, okay. So கொஞ்சம் interact பண்ணாதான் நல்லா இருக்கும். Fine? Okay. Shall we start writing the program? Sorry, shall we start writing the opcodes? Yes. Okay, fine. So this is about our program. Okay, I will ask someone to tell the opcode. Classroom 2 la nama polam. Okay, roll number 19L 243 Sneha Rupa. 19L 243 Sneha Rupa. Kindly respond. Yes, Sneha Rupa. Okay, I will call someone. See, இந்த chatல டைப் பண்றதெல்லாம் அவாய்ட் பண்ணிக்கலாம்ப்பா. See, உங்களுக்கு மைக் வேலை செய்யல அப்படின்னு சொல்றீங்க, ஃபைன். பட் நம்ம இந்த ஆர்குமெண்ட்ஸ்லாம் வேண்டாம். Okay. See, kindly unmute and speak when I am calling your name. Okay. 19L 253 Venkata Prasad. Yes, fine. Venkata Prasad, can you tell the output for LDA instruction? LDA 99000. Yes. Okay, you refer and tell. You refer the opcode sheet, okay, or you refer the previous program. So adli LDA instructions use பண்ணிருக்கோம், correct? Okay, classroomல போஸ்ட் பண்ணிருக்கோம் கண்ணா opcode sheet டவுன்லோட் பண்ணிக்கோங்க, நிறைய தடவை சொல்லிருக்கோமே. Fine, you refer and tell. Okay, classroom 1 la you can type it in the chat. Classroom 1 la opcode உங்களுக்கு தெரிஞ்சதுன்னா டைப் பண்ணுங்க chatல. LDA 9000H. So it's a 3-byte instruction. Very good, Lokas, Nega, Shivakumar, Danya, very good. Classroom 2 la நம்ம வந்து வெங்கட பிரசாத் கேட்டிருக்கோம், வெங்கட பிரகாஷ். Okay, very good. 3A, then so மேல opcode வந்து 3A. How will you write the address? இதுக்கு நம்ம opcode sheet பார்க்கணும்னு அவசியம் கிடையாது வெங்கட பிரசாத். Yes, Venkata Prasad. See, இதுக்கு நீங்க எதுவுமே ரெஃபர் பண்ணணும் அவசியம் கிடையாது. Many times we are doing. See, இது almost நம்மளோட 5th lab session. See, what about the size of the address? You tell me. 16-bit. Fine. Whether 16-bit can be stored in a single memory location? Yes. Okay, fine. Then you are not listening to the class. Correct. See, 16-bit நம்ம ஒரு மெமரி லொகேஷன்ல ஸ்டோர் பண்ண முடியுமான்னு கேட்டேன். Venkata Prakash, I'm not asking about the memory address. I'm asking you this address 9000. இத ஒரு மெமரில ஸ்டோர் பண்ண முடியுமா? ஒரு 16-bit வேல்யூவை ஒரு மெமரி லொகேஷன் 1 byte லொகேஷன்ல போய் ஸ்டோர் பண்ண முடியுமா? It is not possible. How it is possible, Venkata Prasad? Okay, I will ask someone else. Okay, roll number 19L311, Diksha. Roll number 19L311, Diksha. Okay, how we have to write the address value 9000 in memory? Very good, Diksha. Lower byte first, then we have to write the higher byte. What about the lower byte now, Venkata Prasad? You can tell. 9000 lower byte is it? Okay, fine. Diksha, you tell. Very good. 00. What about higher byte? Very good. Okay, fine. Thank you. Okay, now we will go with classroom 1. Classroom 1 la almost chat la type பண்ணிட்டு இருக்கோம் எல்லாரும். Fine. Move B, A க்கு output என்னப்பா? I will ask someone. 19L113 இளைய பாரதி. 19L113 இளைய பாரதி. இளைய பாரதி, are you there? Okay. 19L132 Mega Prasad. 19L132 Mega Prasad. Adlin ma'am, இவங்க நேம்ஸ் எல்லாம் நோட் பண்ணி வச்சுக்கோங்க மேம். ரெஸ்பாண்ட் பண்ணல அப்படின்னு சொல்லிட்டு ஆப்ஷன் மார்க் பண்ணிடலாம். ஓகே, ரோல் நம்பர் 19L140 சண்முகவேல். Okay, roll number 19L146 Sudarshan. No response. Okay, fine. Okay, roll number 19L317 Harshini. Classroom 2 la. 19L317 Harshini. Yes, kindly can you type the opcode for move B, A instruction? Harshini, what is the opcode for move B, A instruction? Kindly refer the opcode sheet and tell. See, lab session வந்துட்டோம்னா opcode sheet பக்கத்திலே வெச்சுக்கோங்கப்பா. Yes. Okay, we'll call someone else. 19L308 Balamurugan. 19L308 Balamurugan. See, okay, what is the opcode for the instruction move B, A? Yes, Harshini typed the answer. Okay, thank you, Harshini. 47. Okay. Balamurugan. Okay, now you tell the opcode for LDA 9001 instruction. 3A, very good. Then 01H 90. Okay, fine. Okay, thank you. So classroom 1, Suresh Aravind, 19L148. Suresh Aravind. Suresh Aravind. Okay, 19L201. Agalya Preeti.
Sir.
Can you tell the output for move C, A? (19L201). Ahalya Preeti, can you tell the output for move C, A? Yes. No response. Ahalya Preeti, chat la potukangala. See, you can unmute and say, because anybody are typing in the chat. Okay, அடுத்த instruction oda outputs la போட்டுட்டு தான் இருக்காங்க. Fine. 4F Agalya Preeti 4F nu போட்டுருக்கீங்க. Yes, 4F, very good. Okay, then XRA A instruction, the output is AF. Then move D, A, the output is 57. Add B, the output is 80. Fine, very good. Coming to this instruction, you have to get familiar, especially when writing the output for branch instruction. Okay, so JNC skip பண்றது எங்க லேபிள் பண்ணிருக்கோம் பாருங்க. In the instruction DCRC, it is available in 800F. So JNC 800F must come here. Okay, so skip அப்படின்றது label actually இங்க என்ன வரணும் 800F. Okay, now you people can tell. I will ask someone else. 19L219 Karthikeyan. 19L219 Karthikeyan. Karthikeyan.
Sir.
Okay, now you tell the output for this instruction JNC skip. The skip பண்ற இடத்துல 800F வரணும்னு சொல்லிட்டேன் because the label skip is mentioned near 800F. Okay, can you type it in the chat? இந்த இன்ஸ்ட்ரக்ஷனுக்கு என்ன outputs வரும்? Can you tell? கார்த்திகேயன் D2 okay. D2 க்கு அப்புறம் என்ன வரும்? What must come after D2? Kindly unmute and speak. Yes. பாருங்க சிவகுமார் ஹெல்ப் பண்றாரு உங்களுக்கு. கார்த்திகேயன் D2 க்கு அப்புறம் என்ன வரணும்பா?
Sir.
After D2, what must come? See, D2 சொன்னீங்க. D2 okay. D2 க்கு அப்புறம் என்ன வரணும் அப்படியே சொல்லலாமே வா. Your voice is audible.
Sir, OF80 sir.
0F80. Okay, thank you. Very good, thank you. Okay, INRD, next instruction INRD, the output is 14. Okay, DCRC, the output is 0D. Okay, again coming to JNZ, we'll go with someone. Okay, roll number 19L301, Abhinesh. See, at least நீங்க ரெஸ்பாண்ட் பண்ணீங்கன்னா அட்டெண்டன்ஸ் கொடுப்போம்பா. ரெஸ்பாண்டே பண்ணல அப்படின்னா நீங்க கிளாஸ்ல இல்லைன்னு தான் அர்த்தம். கரெக்டா? Physically you are not present in the class. Abhinesh, kindly respond. No response. Okay, 19L314 Divija. 19L314 Divija. No response. Okay. 19L320 Kavin. 320 Kavin. 19L320. Yes. Now you tell the output for the instruction JNZ next. Next ன்றது எங்க போட்டுக்கும் பாருங்க label address. What is the label address for next? The label oda address என்ன பாருங்க next. Where it is written in the label column? Here. Correct? So what is the address we are having? Kindly type it in the chat. I am pointing the cursor there. next அப்படின்றது எங்க லேபிள் பண்ணிருக்கோம்பா? Yes, 800A. So now you tell the output for JNZ 800A. Kindly type it in the chat or you just unmute and speak. JNZ ka output enna first? Yes, very good. C2. What about the address? C2 correct. அதுக்கப்புறம் address என்னது? 800A எப்படி எழுதணும்? Yes, very good. 0AH then 80H. Very good. Okay, thank you. Fine. So as there is no space, so we are going to continue from the next page. Kindly take a screenshot. Your screenshot எடுத்துக்கோங்கப்பா. Kindly take a screenshot. I will move to the next slide. Yes, shall I proceed? Yes. Okay, fine. Okay. So in the instruction நமக்கு already தெரியும். STA 329500 must be written as 00 lower byte and 95 higher byte. Then move A, D 7A. Then 320195. Then finally HLT halt instruction. That's all. Okay. So that's all about the program. So kindly take a screenshot of this also. Fine. Now it's time to run the program in the trainer kit. So trainer kit la the program run பண்ணி பார்க்கலாம். Okay. Yes, shall we proceed? Output la note பண்ணிருப்பீங்க நான் நம்புறேன். Fine. So now we will start working in the trainer kit. Okay. First I am going to stop the presentation. Okay, now I am going to present the entire screen. Okay, fine. Is the trainer kit is visible in both the classes? Wait a minute, I will adjust. Then you people see. Yes, is it visible in both classes now? Classroom 2 la யாராவது unmute பண்ணி சொல்ல முடியுமா? Okay, fine. Thank you. Fine. So now I am going to turn on the trainer kit. Fine. Okay. So now you people tell how to write the program, how to type the program in the trainer kit. Okay, I will call someone. Okay, roll number 19L115, Gokul Raj. Sorry, Gokul Kannan, sorry. Gokul Raj, 19L115, Gokul Raj. Okay, 19L114, Giridharan. No response. Okay. ETL error கூப்பிடலாம். Fine. 19T116 Sambat. 19T116 Sambat. Okay, 19T119 Sri Vishnu Kumar. 19T119 Sri Vishnu Kumar. Okay, 19T 120 Vijay Sachin. Okay, fine. I think many of you are getting into the meat. Okay, but you peoples are not listening to anything. Okay, we can clearly able to understand what you peoples are doing. Okay, respond பண்ற யாரையா கூப்பிடலாம். 19T 115 Shakti Abhirami. Shakti Abhirami. 19T 115 Shakti Abhirami. Okay, ma'am. Okay, 114. Giridharan mic work agலையா? ஓகே எண்ட் ஆஃப் த செஷன் நீங்க வெயிட் பண்ணுங்க ஓகேவா செக் பண்ணி பார்க்கலாம் என்ன ப்ராப்ளம் ஓகே ஃபைன் ஓகே ஐ டோன்ட் வாண்ட் டு வேஸ்ட் மை டைம் ஓகே பிகாஸ் மெனி பீப்புள்ஸ் ஆர் ஈகர்லி சீயிங் ஓகே அவுட்புட் பார்க்கணும் அப்படின்னு சொல்லி இருப்போம் ஃபைன் anyone interested from A classroom 1 okay not A classroom 1 you can say which key I have to press now. Yes, very good. Exam memory key I have to press. Fine. So after pressing the exam memory key, I'm getting a dot in the address field. It means it is asking us to enter the starting address of the program. Okay. So obviously where we have started our program? Yes, 8000. Very good. So I'm going to type 8000. Fine. After typing the address, what we have to do? After typing the address, what we have to do? Yes, very good. We have to press the next key. Okay, I have pressed the next key. Okay, now anyone unmute and tell the outputs quickly. Now anyone kindly unmute and tell the outputs.
3A.
3A. Okay, very good. 00.
90.
90.
47.
47.
3A.
3A.
01.
01.
90.
90.
4F.
4F.
AF.
AF. Okay, AF.
57.
57.
80.
80.
D2.
D2.
0F.
0F. 80. Next.
14. 0D.
Wait a minute. 14. 14. 0D.
C2. C2.
C2.
0A.
0A.
80.
80.
32.
32.
00.
00.
95.
95.
7A.
7A. Okay, fine. 7A.
32.
32.
01.
01.
95.
95. 76. Correct?
Yes, sir.
Okay, fine. See, after enter 76, I have pressed next. Fine. So now we can check. Okay, classroom 2 la yaravadhu unmute panni pesa mudiyuma? Classroom 2 la. Anyone from classroom 2? Venkata Prasad typed exam memory. Okay, exam memory press பண்ணிட்டேன் Venkata Prasad. Next என்ன பண்ணணும்? Next what we have to do Venkata Prasad? Yes, 8000. Fine. Next. Tell me the opcode. Unmute பண்ணி சொன்னாதான் நான் கேட்கும். இன்னொன்னா டைப் பண்ணீங்கன்னா டைம் ஆயிடும். கரெக்ட்டா? opcode சொல்லுங்க. கரெக்ட்டா இருக்கான்னு ஒரு தடவை செக் பண்ணிக்கலாம். Venkata Prasad. நான் பேசுறதே பிரேக் ஆகி தான் கேக்குதா? உங்க வாய்ஸ் ஆனா எங்களுக்கு கிளியரா கேக்குது, நீங்க சொல்லுங்க. கரெக்டா? ஆப்கோட்ஸ் மட்டும் வரிசையா சொல்லுங்க. அப்படியே சொல்றீங்களா? ஓகே, somebody else? வேற யாராவது கிளாஸ் ரூம் 2ல வேற யாராவது சொல்லாமே ஆப்கோட்ஸ், so that we can verify. கார்த்திகேயன் 19L 3A, thank you. 3A 00 90 47 3A 01 90 4F AF 57 80 D2 0F 80 14 0D C2 0A 80 32 00 95 7A 32 01 95 76. Thank you. I think it's Sajish, correct? Okay, thank you, Sajish. Okay, fine. Okay, now we have to input the data, correct? Data input nama kudukanum. Okay, can anyone type it in the chat? Gokul Raj, kindly unmute and speak.
Sir.
Gokul Raj, you tell two data. ரெண்டு நம்பர் நம்ம சொல்லலாம், சரிங்களா? ஒன்னு மல்டிப்ளிகன், இன்னொன்னு வந்து மல்டிப்ளையர். மல்டிப்ளிகன்ட் எங்க இருக்குன்னு சொன்ன ஞாபகம் இருக்கா? Where the multiplicand must be there in our program. I mean, where the data must be there, so that my program works.
75 sir.
75 ஒரு டேட்டா கொடுக்கலாமா? எந்த மெமரியில ஸ்டோர் பண்ணணும் 75?
04 சார்.
எந்த மெமரியில ஸ்டோர் பண்ணணும்? ஓகே, கிட்ல நான் எப்படி அந்த டேட்டாவை என்டர் பண்ண முடியும்? இன்புட் டேட்டாவை என்டர் பண்ண முடியும்
சார் 900H மெமரியில சேவ் பண்ணலாம் சார்.
ஓகே, அதுதான் கேக்குறேன். இந்த ட்ரெய்னர் கிட்ல எப்படி பண்ண முடியும்? நம்ம ஃபர்ஸ்ட் எந்த கீ பிரஸ் பண்ணணும்? இந்த ட்ரெய்னர் கிட்ல நான் டேட்டா இன்புட் கொடுக்கிறதுக்கு ஃபர்ஸ்ட் எந்த கீ பிரஸ் பண்ணணும்? மெமரி கண்டென்ட் மாத்தணும்னா
எக்ஸாம் மேம் சார்.
வெரி குட், எக்ஸாம் மேம். ஓகே, எக்ஸாம் மேம் பிரஸ் பண்ணியாச்சு. ஸோ 9000 சொன்னீங்க, கரெக்டுங்களா? 9000 இந்த அட்ரஸ்ல போயிட்டு ஃபர்ஸ்ட் டேட்டா என்ன சொன்னீங்க? 75, கரெக்ட்?
எஸ் சார்.
இன்னொரு டேட்டா என்ன சொன்னோம்? 04. அடுத்து சஜீஷ் சார் ஒரு டேட்டா கொடுத்துருக்காங்க, ஓகேவா? சாட்ல 0502. அதை நெக்ஸ்ட் ட்ரை பண்ணி பார்க்கலாம். ஃபர்ஸ்ட் இந்த டேட்டா இன்புட் நான் கொடுத்துட்டேன். ஃபைன். ஸோ ஐ வில் செக் த டேட்டா இன்புட் ஒன் மோர் டைம். 7504. ஃபைன். ஓகே, தேங்க்யூ.
ஓகே சார்.
ஓகே, வேற யாராவது? Okay, anyone can you tell how to execute the program? Memory, I mean 8000 I have typed the program. Okay, 9000 I have typed the data. Okay, so what we have to do? Shivakumar typed go key. Yes, we have to click on go key. Next, what we have to type? Starting address of the program or data? Yes, very good, Anthony Surya. We have to type 8000. Fine. So after that, what we have to do? We have to press on execute key. Fine. So now the kit is under the control of our program, multiplication program. Fine. The last instruction we have written is halt. Fine. That means my program is getting executed in the trainer kit now. So none of the key is working. Fine. To get the kit to the monitor routine control, what we have to do? Yes, we have to press on reset. Okay. Now you people tell me where the result will be there. Where the result will be there? Nam program la enga result store pannirnom? 9500. Very good. Exam mem 9500. Next. D4 is the result of lower byte of the result. 01 is the higher byte of the result. This is what we have explained in the PPT also, correct? இப்போ சஜி சார் கொடுத்த டேட்டாவை போட்டு பார்க்கலாம். Okay, now we will substitute the data which suggested by Sajish sir. Okay, one is 05, the another one is 02. Can you people type the answer? What answer you are expecting? 05, correct? Hexadecimal number into 02, hexadecimal number. Okay, Sajish sir வந்து execute பண்றதுக்கு முன்னாடி output என்ன வரும்னு உங்களை சொல்றாங்க, correct? Shivkumar typed 0001. Okay, anybody else? 05 into 02, we are performing hexadecimal multiplication, don't forget. Yes? It's wrong, Shivkumar. Kindly check and tell. See, the question is, what will be the result? Yes, in second classroom, Sajish typed the correct answer. Very good, Sajish. What about in classroom 1? Kindly think and tell. I have told you, I have stressed you, it's hexadecimal multiplication. Any idea? See, 5 into 2 நம்ம என்ன சொல்லிருக்கோம்? 2 times 5 add பண்ணுங்க. 00 plus 05, we will get 05 only. Again 05 கூட 05 add பண்ணுங்க. என்ன வரும்? What about the result? In decimal addition, you will get what? 05 plus 05, decimal addition என்ன வரும்? But here we are using hexadecimal addition. That means it's performing the binary multiplication. That means the number 75 means 0111. Yes, yes. Who told the answer? I think somebody told the answer. Who told the answer?
Sir. Anthony Surya, sir.
Okay, very good, Anthony Surya. Yes, many of you are typing the answer. 0A is the correct thing. Fine. Okay, shall we execute the program now? Go 8000 and I am executing the program. Reset exam memory. Go to the memory 9500. Next, you are getting the result as 0A. There is no higher byte. That's all. Okay. Okay, now I have one more question. What is the maximum possible bigger 8-bit data? What is the maximum possible 8-bit data? What about the maximum possible size of an 8-bit data? Value, not size. Yes, very good, Shivakumari. FF. Shall we give 2 operand with same value FF? Okay, in 9000, I am going to give the value as FF. Okay, so FF multiplied by FF. Okay, go 8000, execute. Okay, now I am going to reset exam memory 9500. Lower byte of the result is 01, higher byte is FE. FE01 is the answer. Kindly note down this. 01 is the lower byte of the value of result. FE is the higher byte of the multiplication result. Okay, fine. So trainer kit நம்ம work பண்ணத stop பண்ணிக்கலாம். Now we will continue in the simulator. Okay, so hereafter we are going to work with the simulator. Fine. Okay, I hope everyone understand this program. Multiplication program புரிஞ்சுதா எல்லாருக்குமே? See, the problem is many of you peoples are not interacting. Okay, many of you peoples are not listening. That's the problem we are facing. Okay, fine. Thank you. Okay, now it's time to work in the simulator. Okay, wait a minute. Okay, fine. I will start present from my mobile phone also. Wait for some time. Okay, can you people see my mobile phone screen? Yes. Kindly type it in the chat so that I can know. Yes, okay, fine. Thank you. Okay, now I am going to open the app. Fine. First, we will go with the PPT. Okay, then we will continue with programs. So we have completed all the programs, okay, which doesn't involve any hardware connection. Okay, interfacing எதுவுமே நம்ம இது வரைக்கும் பண்ணல. Fine. So totally we have done. I think experiment 1ல 2 பண்ணிருக்கோம், 2 2 பண்ணிருக்கோம், 3ல 2 பண்ணிருக்கோம். Today 1 program. Totally 7 programs we have finished. Correct? Yes. Is the PPT is visible to all of you? Yes. Visible or PPT?
Yes, sir.
Okay, fine. Okay. See, for an example, now we have done multiplication program. So this is our lab program. Okay. So in the program na எல்லாருமே நம்ம லேப்ல record and observation la எழுத போறோம். Fine. Any other program logic to perform 8-bit multiplication? Okay. See, concept on the repeated addition da adula endha doubt kediyadhu. Fine. Is there any other way to implement it in the program in different way? Shall we go one by one? What is the maximum possible value of an 8-bit data? Kindly type it in the chat. Yes. FF. Very good. Very good. Okay, fine. Now, what is the maximum possible value of multiplication of two 8-bit data? Maximum possible result. Maximum value. The maximum number FF you told. So the multiplication of FF and FF yields FE01. Correct? Okay, what you are inferring from this result? Already in digital we have studied this. When I am multiplying two 8-bit data, what about the size, maximum size of the result? How many bit? Yes, very good, 16-bit. Okay, so that is the key point I want to tell you. Okay, so that you can think in different way. Now, any idea to perform the multiplication? 2 8-bit data va na multiply pannanom. Fine. So where the possibility irukka na ketirken question. Fine. Yes, very good, Danya. Very good. What I have expected, Danya typed using register pair. Is it possible to implement 8-bit multiplication process using 16-bit addition? Yes. Fine. The only difference is size of the memory. Correct? So anga nama 8-bit pannom addition, repeated addition. So inga nama panna poradhu enadhu 16-bit repeated addition. Okay. Can you people type it in the chat? Which instruction we have to use for 16-bit addition? Yes, very good. DADRP. Which register pair of 88, 85 must be used during 16-bit addition? That means one of the operand must present in which register pair? Very good. HL. What about the result of 16-bit addition? Where it will get stored? It will get stored in HL register pair itself. Fine. So these are the answers I am expecting from you peoples. Okay. So inga nama carry varudha illiyandradala check pandrom correct ah. carry வந்துச்சுனா ஒரு register increment பண்றோம். Fine. Here what we have done is one logic. Fine. Concept is same. Repeated addition is the only solution for performing multiplication. Fine. Okay. So now how it can be done? எப்படி பண்ணலாம் அப்படின்றதுதான் கேள்வி. Fine. So இங்க நமக்கு initial sum எங்க இருக்கணும்? அங்க accumulatorல இருந்துச்சு. இங்க எங்க இருக்கணும்? What about the initial sum? Where it must present? HL. What about the value? HL register pairல என்ன value இருக்கணும்? Before starting the repeated addition? Logos Nega, kindly check. We are speaking about register pair. Fine. So let the 8-bit multiplicand be XX ன்னு எடுத்துக்கலாம். Data XX ன்னு எடுத்துப்போம். அதே மாதிரி multiplier வந்து YY ன்னு எடுத்துப்போம். Fine. So now HL ல கண்டிப்பா 0000 இருக்கும்னு சொல்லியாச்சு. Fine. We can take some other register pair. We can consider BC register pair. BC register pairல என்ன value இருக்கணும்? Any idea? What about your multiplicand? XX, where it must be placed in BC register pair. BC register pairல value எப்படி நம்ம store பண்ணிருக்கணும்? Yes, BC ல multiplicand இருக்கணும். Fine. But our multiplicand is 8-bit, but BC register pair is 16-bit. So how it should be present in BC register pair? என்னோட multiplicand higher byte ல இருக்கணுமா lower byte ல இருக்கணுமா? Can you type it in the chat? XX ன்னு சொல்லிட்டேன் பா, multiplicand வந்து XX ன்னு சொல்லிட்டேன். Correct? So higher 0000 ன்னு டைப் பண்ணிருக்கீங்க ஆண்டனி சூர்யா, kindly check it. So how it should be stored in the register pair BC? What Anthony Surya told is correct, but அவங்களோட representation வந்து கொஞ்சம் தப்பா இருக்குது. Higher 0000 போட்டோம்னா multiplicand போடுறதுக்கு இடம் இருக்காது. Yes, very good, very good. Anthony Surya, very good. B registerல 00 இருக்கணும். கரெக்டா? C registerல the value XX must present. Correct? So இங்க 7504 பதிலா XXYY அப்படின்னு மென்ஷன் பண்ணிருக்கோம். Fine. Very good, very good. Okay. Okay. We need one more register to store the multiplier. இந்த register யூஸ் பண்ணிக்கலாம் நம்ம. இங்க DE யூஸ் பண்ணிருக்கோம் பா, சாரி. Instead of BC, here we use DE. Okay. No issues. So இப்ப D registerல 00 இருக்கணும். E registerல என்ன இருக்கணும்? XX must be there. Sorry. Fine. Actually, when I am asking the question, BC register pair somehow, but here in PPT, I used to put it in DE register pair. Fine. So we have to use some other register to hold the multiplier value. That means count value, YY. Fine. So this is what we have to initialize. After done this, how we can perform? How we can perform repeated addition? So we have to do repeated addition of DE register pair content with HL register pair content. Okay, multiplier times. Okay, so YY count 0 ஆகிற வரைக்கும் repeated addition பண்ணிட்டே இருக்க போறோம். That's all. So after the repeated addition, H register hold the higher byte of the result and L register hold the lower byte of the result. That's all. Fine. Okay. Shall we go with the program? Shall we go with the program? Yes, fine. So first line என்ன எழுத போறோம் அப்படின்னு பாத்தீங்கன்னா, what we have to do? மெமரியில இருந்து டேட்டாவை எடுக்கணும். கரெக்டா? From memory we have to take the data. 2 bytes simultaneously எடுக்கணும்னா எந்த இன்ஸ்ட்ரக்ஷன் யூஸ் பண்ணலாம்? I want to take 2 bytes from the consecutive memory location. Okay, so which instruction we can use? 16-bit data from memory. Not SHLD Danya, kindly check it. LDX கிடையாது Dixon. No. 2 byte டேட்டாவை மெமரில இருந்து நான் லோட் பண்ணா கண்டிப்பா எங்க லோட் பண்ண முடியும்? Register pair only. Fine. Yes, very good Danya. LHLD. Fine. LHLD 9000. So you keep on tracking your data. Fine. Multiplier எங்க வரும்? Multiplicand எங்க இருக்கும்? 9000ல எது இருக்கும்? Multiplicand. அது எங்க போய் ஸ்டோர் ஆகும்? Where the multiplicand will be there in the HL register pair? HL register pairல multiplicand எங்க இருக்கும்? Multiplier எங்க இருக்கும்? யோசிச்சு பதில் சொல்லுங்க. எந்த அட்ரஸ் நான் மென்ஷன் பண்ணிருக்கனோ அதுல உள்ள டேட்டா எல் ரெஜிஸ்டருக்கு தான் வரும். கரெக்டா? அதுக்கு அடுத்த மெமரியில உள்ள டேட்டா ஹெச் ரெஜிஸ்டருக்கு வரும். My question is where the multiplicand and multiplier are available now. Yes? Any idea? Yes, L registerல multiplicand இருக்கும். கரெக்டா? Very good. H registerல என்ன இருக்கும்? Multiplier. Okay. So நம்ம எழுதுற லாஜிக் படி போன ஸ்லைட்ல பார்க்கலாம். Okay. E registerல multiplicand இருக்கணும், C registerல multiplier இருக்கணும். கரெக்டா? So what we have to do? Move E, L. Multiplicand is moved to E register and the count value is moved to C register. Correct? Okay. Once I have done this, whether we need HL content now? இது பண்ணி முடிச்சதுக்கு அப்புறம் HL register pair again என்ன பண்ணணும் நம்ம? What we have to do? Just refer the previous slide. Yes, we have to clear it. So for that, what we have to do? HL register pair 0000 value I have to put an immediate value. So for that, what we have to do? Which instruction we have to use? MVI 8-bit data for 16-bit data to register pair. Very good Danya. LXI H, 0000. Fine. So side la na mention பண்ணிருக்கிறது number of bytes occupied by the instruction. Okay. So அதுவும் சைடுல நோட் பண்ணி வச்சுக்கோங்க. Fine. Okay. இப்போ நல்லா கவனிச்சு சொல்லணும். E registerல multiplicand இருக்கு, C registerல multiplier இருக்கு. Okay. HL register pair clear பண்ணியாச்சு. Okay. இன்னும் ஒரே ஒரு விஷயம் பண்ணணும், பார்த்து சொல்லாமே. இந்த வேல்யூ 00 HL போயாச்சு. E registerல XX வந்தாச்சு, C registerல YY வந்தாச்சு. Still one more thing we have to do. What is that? Before performing addition, the other register pair content. Okay, அதுல lower byte ல multiplicand இருக்கணும். Okay, what about the higher byte? D registerல என்ன வேல்யூ இருக்கணும்? No carry. இங்க நம்ம கேரிக்கு வாய்ப்பே கிடையாது. நம்ம பண்ண போறதே 16-bit addition தான். கரெக்டா? என்னோட ரிசல்ட் 16-bit தாண்டி போகவே போகாதுன்னு சொல்லி பார்த்தாச்சு நம்ம. Fine. There won't be any carry. இப்போ என்ன கண்டிஷன் நான் சொல்லவா? HL register pair we have 0000. Fine. What about in D register pair? D registerல என்ன கண்டென்ட் இருக்குன்னே தெரியாது. E registerல என்னோட multiplicand value இருக்கு. Correct? So what we have to do with D register? போன ஸ்லைட பார்த்து சொல்லுங்க. D registerல என்ன இருக்கணும்? What must be there in D register? On seeing the slide you can tell. Yes, very good. 00. Fine. So already நமக்கு HL ரெண்டுலயும் 00 தான் இருக்கு. So move D, H யூஸ் பண்ணலாம் or move D, L ஏதோ ஒன்னு யூஸ் பண்ணிக்கலாம். Fine. Already H register content is 0, so I'm copying it to D register also. Fine. That's all about the initialization. In the step we achieve பண்ணியாச்சு. This step we have achieved. Okay. Fine. So now we can continue. 16-bit addition. To perform 16-bit addition, what instruction we have to write now? Which instruction we have to write now? Yes, DAD. What about the other register pair we want to add? DAD, what must come? Yes, very good. DAD D. Fine. Okay, now addition is over. Okay, first time addition is over. Where the multiplier is there, count value எங்க இருக்குன்னு சொன்னோம்? C register la irukku correct count 0 இல்லையா check பண்ணனும். What we have to do? Which register we have to decrement? One time I have performed the 16-bit addition. Very good. DCRC, if it is no 0, where the label must be put? It's very interesting question now. The repeat in the label, and the instruction munadi poduvinga. Can you people tell where you will label the repeat instruction? Very good Anthony Surya, very good, fine. See, nalla oru vishayam purinjikkanum. Initialization up to the 5 lines 1 2 3 4 5 up to move D, H we have done initialization. So inge da nama addition start pannirkom, correct? So repeated addition means you have to do in this way, correct? Again we are performing the addition, decrement the count till count gets 0. We are repeating it again and again. That's all. Fine. Okay, now you people tell me where the result will be there after coming out from the loop. Where the result will be there? Result enga irukum pa? Very good. In HL register pair, to store it in memory location, consecutive memory location 9500 and 9501, which instruction we can use? STHLR. Kindly check it, Shivakumar. Yes, very good, Danya. SHLD 9500H. Very good. That's all. So that's all about the program. Okay. Shall we execute the program now? Simulator la work panni paakalangala. Shall we proceed? Yes, fine. So now I am going to what about the screen? Wait a minute. I think something happened. Wait a minute. My mobile screen is not presenting. Wait a minute. I will check what about the problem. Wait a minute. I'm having some issue with the connectivity. Wait a minute. I will do it. Wait for some time. It will be ready in minutes. Yes. Okay. Yes. Is it visible now? Wait a minute. I will make the font size little bigger so that everybody can see it. Okay, fine. So now I am going to type the programs. The same program I am going to type it here. Okay. So LHLD 9000H, then move E, L, then move C, H, LXI H comma 0000H move B comma H, then DAD B, BCR C, JNZ I'm making it with small label REPD போட்டுக்கிறேன். SHLD 9500H. Fine. Then HLT. Okay. I missed one thing here. The JNZ REPT போட்டுக்கோம் இல்லையா? So the எங்க label பண்ணணும்னு சொன்னோம் DAD D க்கு முன்னாடி, correct? REPT. Okay, fine. See, generally you have the habit of alignment like this, so that we can identify which one is label and which one is mnemonics. So கொஞ்சம் நமக்கு ஈஸியா அண்டர்ஸ்டாண்ட் பண்ணிக்கிறதுக்கு இருக்கும் ப்ரோக்ராம் பார்த்தோம். So now you can see. So after I have typed the program, what we have to do? We have to click on the save icon. I'm giving the name 8-bit mul. Okay, saving the program 8-bit mul. Okay, so after I have saved the program, what I'm going to do is I'm going to click on the upper circle, which is the load button. So 8000 address la program load pandrom. The program got loaded now. Okay, now we have to give the input data. Fine. So in 9000, I am going to give the value FF FF. Okay, I have given the data as FF, the maximum data, so that we can test the program for all conditions. Okay, so now we can run the program. So I am running the program. Okay, it takes more time, I think so. Sorry. So count value வந்து நமக்கு full decrement ஆகுற வரைக்கும் வேடிக்கை பார்த்துட்டே இருக்க வேண்டியதான், so that I can stop. Okay. So count value கொஞ்சம் கம்மியா கொடுத்துட்டு ட்ரை பண்ணி பார்க்கலாம். Can give it as some 5 times we can give. See, maximum conditions வந்து நம்ம கிட்ல பண்றப்ப ஃபாஸ்டா ரன் ஆயிடும். As it is simulator, இல்ல லைன் பை லைனா தான் நமக்கு எக்ஸிக்யூட் ஆகுற மாதிரி பண்ணிருக்கேன். Fine, it takes more time. Now you can see. So now the result FF into 5. That means we have to check it in 9500. Yes, FB04. That is the correct answer. Okay, that's the correct answer. Is it clear to all of you? Is it clear to all of you? Yes. Okay. Now my question is, how this program save the memory space? Sorry. Actually, here, how many bytes we have used for this program? Can you people type it in the chat? Just count it and type it in the chat. Total எத்தனை byte நம்ம யூஸ் பண்ணிருக்கோம் இந்த program எழுதுறதுக்கு? Yes. 3, 4, 5, 8, 9, 10, 11, 14, 17, 18. Very good. 18 bytes. Okay. What about the number of bytes we have used in the previous program? Can you count and tell? Here you can count. I think Anthony Surya typed the answer. 26. Correct? By seeing the end address, you can say 1A. Okay. Yes. 16 plus A means 10. 26. 28 are. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I think 27 locations, correct? We have used 27 bytes. Anton Surya, kindly check it. Am I correct? $28 or $27? Okay, anyhow. So when compared to this program, okay, the program what we have executed now, this program, that program occupies more memory space. Okay, when especially we are designing an embedded application, memory is the very important constraint. Okay, see, you have to write the optimal coding because in embedded system you will be having not a sophisticated size of memory. Okay, see, namoda computer eduthukkonga, you can have a hard disk of 1 TB, something like that. Okay, when we are going for embedded system, the memory size is still, we are having only lesser memory one. Fine. So neenga Raspberry Pi அப்படினு சொல்லிட்டு ஒரு board இருக்கு. Fine. Like your Arduino board. Okay. So it is capable of having an SD card storage. SD card storage நீங்க போட்டுட்டு we can go with up to 4 GB of memory. Fine. See, when we are going for embedded system, embedded application, there the memory is the real constraint. So we have to write the optimal code. Fine. I can't say this is the optimal program for multiplication. You may have some other logic also. Fine. So நம்ம உட்கார்ந்து யோசிச்சு எழுதுனதுல இது ஒரு ஆப்டிமல் ப்ரோக்ராம் நான் சொல்றேன். கரெக்ட்? Fine. Even better, இதை விட பெட்டரா உங்களால எழுத முடியும். That means multiplication program அப்படின்னா இப்படிதான் பண்ணணும்னு கிடையாது. You can have many logic. Fine. The other way, the other thing what you have to consider is time of execution. Memory மட்டும் பார்க்க முடியாது. The time of execution. That's why the performance can be improved. Fine. So program oda size கம்மியா இருக்கணும். அதே நேரத்துல the execution time also will be optimal. Fine. Are you able to understand what I'm saying? See, அப்ப நம்ம ஒரு program சொன்னோம்னா அதுக்கு இதுதான் லாஜிக் எல்லாம் கிடையாது. You can have infinite logic. Many logic you can have for writing any program. Okay. உங்களுக்கு என்ன தோணுதோ அதை வச்சு எழுதலாம். Fine. As a beginner, it is very hard for you people to write optimal coding. Okay. Once you got familiar with that particular platform, you can go with an efficient coding. Okay. So that you can save your memory space as well as you can save the time of execution of the program. Okay. See, we want to tell you that concept. That's why we have the another view of the program. Okay, same 8-bit multiplication we have done, okay, with less number of memory locations. That's all. Is it clear for everyone? Yes. Okay, fine. Now we can have some additional program for our lab. Okay, see, regular we will do more hardware related experiment. Interfacing la panni nam experiment pannuvom. Once you people are coming to college, once you people came to college, okay, we can have such experiment. In that way, we are planning the lab session. Okay, so today we are going to continue with some additional programs. Okay, நம்ம கிளாஸ் எடுக்கிறப்ப சார் ஒரு சில கொஸ்டின் கேட்டிருப்பாங்க. Fine. So அதெல்லாம் சேர்த்து நம்ம என்ன பண்ணிருக்கோம்? Additional programs we can have. So this programs can also be part of your lab experiment now. Okay, usually in the additional program அப்படின்னு சொல்றது வந்து எக்ஸாம்க்கு வந்து 1-2 கேட்போம், 1-2 கேட்க மாட்டோம். But we are truncating more hardware experiment as it is online class. 1 or 2 hardware experiments we will do. Okay, so இதுக்கு அப்புறம் வரக்கூடிய ப்ரோக்ராம்ஸும் உங்களுக்கு என்னது? We can ask it for exam purpose. Okay, so don't think it is additional experiment so that இது எக்ஸாம்க்கு வராது அப்படிலாம் கிடையாது. Fine. The first thing, the very first thing, identify the sign of an 8-bit data in memory address 8500H. Correct? So 8500H ல உள்ள ஒரு டேட்டாவோட சைன் whether it is positive or negative அப்படின்றத ஐடென்டிஃபை பண்ணணும். ஓகே, ரிசல்ட் வந்து என்ன சொல்றோம் அப்படின்னு பாத்தீங்கன்னா, if it is a positive result, positive number, the value must present in 9000 must be 00. Correct? Negative number இருந்தா 01 ன்னு இருக்கும். That's all. Is it clear? Is the problem statement is clear? Yes or no? 8500 ல உள்ள 8-bit data. Okay, we are assuming it is a signed number. Please understand one thing regarding microprocessor. It doesn't know whether it is a signed number or unsigned number. We user in our program, we are interpreting that number as signed number. Okay, நீங்க C ப்ரோக்ராம்ல எழுதுறப்ப என்ன பண்றீங்க, வேரியபிள் அஸ்யூம் பண்றப்ப signed in, unsigned in அப்படிலாம் அஸ்யூம் பண்ணுவோம். What it mean? In user perspective, it is a signed number or unsigned number, like that we are mentioning. But according to the machine, it is simply ones and zeros. It won't know whether it is a positive number or negative number. We people are interpreting that. Fine. Okay, shall we proceed? Yes. Okay, now I will display an 8-bit signed number. Okay, so that you can say whether it is a positive number or negative number. Can you people type it in the chat? You don't worry about the other bits. Very good, Shivakumar. Very good. It's a negative number. Obviously, it's a negative number. Fine. Okay, what about this one? Yes, positive number. So in conclusion, what you will call this particular bit? Can you type it in the chat? MSB. What about in the case of signed number, how you will call it as? How you are identifying that number is positive or negative? With the MSB. Yes, very good. Signed bit. Very good. Signed bit. Correct? So it's a signed bit. Okay. To know whether the number is positive or negative, how you can do the program, or how we can find it. In the particular bit 0 or 1 நான் எப்படி தெரிஞ்சுக்கலாம்? Any methods? Any methods? இந்த particular bit எனக்கு 1 or 0 ஆன்றதை எப்படி ஐடென்டிஃபை பண்ணலாம்? Any methods? Yes. இந்த MSB bit 0 or 1 நான் செக் பண்ணணும். Any methods? Okay, now I will ask you one question. Can I find from carry flag? Or sir asking one question. Can I find from carry flag? So that where the sign bit must go? Any idea, you peoples? See, variety of logic you can say for this particular program. Okay, now I will ask you one question. How to move sign bit to carry flag bit? The sign bit, MSB bit, carry. Very good, Shivakumar. Using rotate operation, we can move the MSB bit to carry. Fine? Okay, fine. Very good, Shivakumar. How you can do? Either by left or right rotation. In which direction we can rotate? Yes, any idea? See, 8-bit data la MSB value carry ki poganum. Correct? So which rotation I can prefer? Shivakumar told the correct answer. We are going to use rotate operation. Fine. When we are rotating the 8-bit data in accumulator, okay, the MSB must go to carry flag. So which side I have to rotate? Yes, very good. Left hand side. By rotate operation only, you can do it with right also. But how many times you have to do it? இங்க உள்ள MSB bit ஒரு தடவை rotate பண்ணா இங்க வரும் 1 2 3 4 5 6 7 8th rotation la da enak enga pogum carry ku pogum when we are using right shift. Okay, so we have to go with left so that oru tharavam nama rotate panna enna agum, this sign bit will get into the carry bit. Fine. Also it get copied to D0. Fine. So idhula rendu rotation irukku, RLC or REL edu venna use pannikalam, no worries. Okay, both are doing one important thing. The MSB bit of a accumulator content is shifted to carry bit as well as LSB bit in the case of RLC. Correct? REL na enna nadakum, sign bit will move to carry will move to D0, the remaining will shift left by 1 bit position. Clear? Okay, now shall we write the program? Concept தெரிஞ்சிருச்சு, என்ன பண்ணனும்? Shall we write the program? மெமரில இருந்து டேட்டாவை எடுக்கணும், கரெக்ட்டா? லெஃப்ட் ஹேண்ட் சைடு ரொட்டேட் பண்ணனும். ஃபைன். ரொட்டேட் பண்ணதுக்கு அப்புறம் என்ன பண்ணனும்? We have to check the carry flag. Correct? Okay, fine. So LDA data எடுத்தாச்சு. Fine. After I have got the data, what I have to do? See, data is now available in the accumulator. What I have to do now? LDA 8500. I have got the data. கொஞ்ச நேரத்துக்கு முன்னாடி சொன்ன என்ன இன்ஸ்ட்ரக்ஷன் யூஸ் பண்ணோம் ரொட்டேட் பண்றதுக்கு? Which instruction? Very good, RLC. Correct? Okay, இப்போ MSB bit 1 or 0 னு எனக்கு தெரியாது. What data I have taken, whether it is a positive number or negative number, that I don't know. Correct? That we don't know. Wait a minute. Okay, here in simulator we will type the program parallelly. Fine. So LDA 8500H. The next line I am using RLC. Fine. Okay. What about the next line? என்ன கண்டிஷன் சொல்லிருந்தோம் ஞாபகம் இருக்கா? If it is a positive number, 9000 ல என்ன வேல்யூ இருக்கணும்? 00 இருக்கணும். If it's a negative number, 9000 ல எனக்கு என்ன வேல்யூ இருக்கணும்? 01. Fine. Okay, to store the result into the memory location, which register we must use? எந்த register நம்ம யூஸ் பண்ணுவோம்ப்பா? To store the value to memory, which register we will use usually? Yes, accumulator register. So what I am doing is I am clearing the accumulator register initially. Fine. Initially நான் என்ன பண்றேன்? Accumulator register clear பண்ணி MVI A,00H. Please note down one thing. I am not interested on the data. I am interested on the MSB of the data. Fine. I have loaded the data from memory and rotated the accumulator content to the left hand side so that MSB is now available in carry. Fine. Now I am not bothering about what? Data. Fine. Okay. So after I have done this, ரெண்டு விதமா நம்ம இத பண்ண முடியும். Okay, ரெண்டு விதமா நம்ம பண்ணலாம். நார்மல் அடிஷன் பண்றப்ப நம்ம ப்ரோக்ராம்ல என்ன எழுதணும் ஞாபகம் இருக்கா? Now we have to know whether the carry is there or not. Correct? So which instruction we can use? Any idea? Accumulatorல 0 இருக்கு. Carry flag இப்ப செட்டா ரீசெட்டா எனக்கு தெரியாது. But it should come to accumulator register. What we can do now? Any idea? The status of the carry has to come to accumulator. Yes, very good. JNC we can use. JNC skip we can use. Very good. Very good. So I am going to use JNC skip. Correct? Okay, sir. Carry vandirundha enna pananum? If we got carry, what we can do? JNC skip. I will type it here also. JNC skip. Okay, if carry occurs, what we have to do? Accumulator initial 0 போட்டேன் கரெக்ட்டா? carry வரலனா இது அப்படியே ஸ்டோர் பண்ணலாம். carry வந்தா என்ன பண்ணனும்? 0 1 we have to store. Very good. 0 1 we have to store. So what we can do is, if carry is there, we have to increment the accumulator content, or else directly store it. நல்லா கவனிங்க, carry இருந்தா accumulator become 1, correct? Or else accumulator கடைசியா என்ன வேல்யூ போட்டோம்? 0 0. So it will get stored to 9000, correct? So that's all about the program. So INR A, sorry, INR A, then skip STA 900H. Then finally we have halt instruction HLT. Okay, now we can run the program, test the program. Okay, now you people tell a number, or positive number type பண்ணுங்க, or negative number chatல type பண்ணுங்க. We will give it as a input data and we can verify the result. You people type it in the chat. ஒரு positive number type பண்ணுங்க, input கொடுத்து பார்க்கலாம், ஒரு negative number கொடுங்க பார்க்கலாம். Kindly type two numbers, two sign numbers. One must be positive, the another must be negative. Okay. Shivakumar வந்து 54 கொடுத்திருக்காரு, அது பாசிட்டிவ் நம்பர் கரெக்ட்டா? 54 னா பைனரி பேட்டர்ன்ல நம்ம எப்படி எழுதுவோம் அத? 54H. So 01015, then 0100. 54. Okay. The another number given by Anthony Surya is C0. Fine. So 54 C0. கொடுத்து பார்க்கலாங்களா? Fine. So now I am going to run the program, load the program. So 8000 la load ஆயிடுச்சு program. Sorry. Okay. So now I am going to input the data. So I have to give the data in 8500, correct? So 8500, we have to give 54 கொடுத்து பார்க்கலாம். First Shivakumar கொடுத்த number 54. Okay. So now we are going to run this program. So it's positive number அப்படினா 9000 ல என்ன இருக்கணும்? 00 must come, correct? So I am running the program. So in 9000 you can see, yes, we are having 01. Okay, now we will give the data given by Anthony Surya. Okay, அவங்க கொடுத்த டேட்டாவை போடுறோம். Okay, now we are going to load the program. Can give the data as C0. Fine. So 9000, sorry, 8500 la I'm going to give the data as C0. C0. Okay, now we are going to run the program. Now we can run the program. Okay, so in 9000 we must have 01 now. Yes, very good, 01, correct? So that's all about the program. Fine. Is it the only one way? Is it the only one way to do this particular programming? We can do it in another way also. Shall we go with it? Yes. Okay. So the same program, but the logic is little different. Is an alternate method to find sign of an 8-bit data? Definitely yes. By performing dummy addition with 0H and check sign flag. That's all. Dummy addition na onnum kediyadhu. Add the content with 00. That's all. Accumulator la enna content irukko the 00 kuda add panna porom. Kandipa ALU operation perform panna enna agum sollirkom, flags will get affected. So ungaloda result la MSB bit 1 irundhuchna kandipa sign flag set aidum. By checking the sign flag you can conclude the number is whether positive number or negative number. Fine. So adukku use pannakudiya instruction enadhu ADI 00H. This we call it as dummy addition here. Fine. Dummy addition ஒண்ணும் கிடையாதுப்பா. அந்த நம்பரை எடுத்து 0 கூட ஆட் பண்ணணும். That's all. Then we are checking jump if positive. Positive இருந்தா jump பண்ண சொல்றோம். Negative இருந்தா accumulator increment பண்ணிட்டு போணும். The same thing. Loading the data from memory. Okay, adding 00 with it. Then after addition, accumulator எனக்கு தேவையில்லை content. Correcta? So I'm moving the immediate data 00 to accumulator. It won't affect the flag content as it is a data transfer instruction. Okay. So after that, JP skip. Positive இருந்தா skip, negative இருந்தா increment பண்ணிட்டு அப்புறம் store பண்ணணும். Correcta? Positive இருந்தா என்ன ஆகும்? Direct 00 will get stored. That's all. Halt. That's it. That's it. It's another way. It's another way. It's another method. Okay, to do the same operation. Fine. I will modify the content now. So I will type that program here. So instead of RLC, what I am going to do? ADI 00H. Okay, dummy addition I have did. So when I MSB bit 1 hour and kandipa sign flag set aidum. So I no need to bother about the data in accumulator. So I'm just clearing accumulator content. So here JP பாசிட்டிவா இருந்துச்சுன்னா இங்க போயிடும். கரெக்டா? நெகட்டிவா இருந்தா இன்கிரிமெண்ட் பண்ணிட்டு இங்க போகும். That's all. So the same program I'm going to run it now. I'm loading it. I will give some random input data now on my own. So 8500 la na or value கொடுத்தேன். 8500. Fine. So C0 முன்னாடி கொடுக்கணும். கரெக்டா? இப்போ நான் கொடுக்க போற டேட்டா என்ன அப்படினு பாத்தீங்கன்னா 84. Some other thing I can do. 37. Fine. Can you people type it in the chat? 37. Whether it is a positive number or negative number. Kindly type it in the chat. Yes. Positive number. Very good. 37 means 00110111. Correct? So the MSB bit is 0. That means it's a positive number. You will see the result now after execution. So now I am going to run the program. As a result, in 9000, I got 00. Correct? Okay. I am going to change the data. I am going to give some other number. 97. So now it's a negative number. When I am running the program, we got the result as 01. It's a negative number. That's all. Is it clear? Is it clear for all of you? Yes. Is it clear or not? Okay. In some other way also I can do it. See, it's not like there is a fixed logic. It's not like that. Okay. Fine. I will tell you. So here you can do in this way also. RLC use பண்ணீங்களா? RLC use பண்ணோம். கரெக்ட்டா? Branch instruction la நடத்துறதுக்கு முன்னாடி I think you people remember before teaching branch instruction we told one instruction to handle carry. Correct? Carry to accumulator கொண்டு வரதுக்கு ஒரு கான்செப்ட் சொல்லிருக்கோம். ஞாபகம் இருக்கா? Anybody is having idea with that? Yes. Without branch instruction, we know how to get carry to accumulator. Yes. Yes, very good, Danya. ADC instruction also we can use. Very good. Fine. So now I am clearing the accumulator. Now I can use what? Simply ADC A. That's all. So here no branch instruction we used. Correct? So get the data to accumulator, rotate it left hand side by 1 bit position, so that if carry occurs, that means MSB bit is 1. If no carry means it's a positive number. Correct? So now clearing the accumulator, ADCA means 0 plus 0 plus. If carry is there, 1 must come to accumulator, or else 0 will come to accumulator. So directly we are storing it to the memory location 9000. That's all. So இந்த ப்ரோக்ராமும் எனக்கு ரன் பண்ணி பார்க்கலாம். Fine, that's all. So here we will see the result. So I will give some random data in 8500. So here we are going to give the number as 77. Okay, now we are going to run the program. So it's a positive number. So obviously the result in 9000 must be 00. So now we will give some other data in 8500. Negative number கொடுத்து பார்க்கலாம். A4. Okay, now we will run the program. So what result we got now in 9000 is yes 01. It's a negative number. Clear? See, don't think there is only one program to do this particular operation like that. Definitely don't think. Okay, you have variety of logic, okay, variety of methods to implement the operation. Fine. Only thing what you have to remember is the program must be an optimal one. It must occupy less memory space. Okay, the program execution speed also you have to consider. Both should be considered when writing the program. So then only you will become a expert programmer. Fine. Next question. So identify the parity of 8-bit data in memory address and store the result in memory address 9100. Fine. So இங்க நம்ம parity அப்படினு சொல்றப்ப here what we are going to do is simply we are going to do dummy addition. Okay, when parity flag bit of 8085 gets set, when the ALU operation result in even parity data, correct? Parity flag வந்து set ஆகும். How to find parity of an 8-bit data? Just by performing dummy addition and check parity flag. That's all. So இதுக்கு program எழுதிடலாமா நம்மளே? So என்ன instruction யூஸ் பண்ணுவோம் dummy additionக்கு? ADI 00H. இங்க parity check பண்ணோம். என்ன parity check பண்ண போறோம் அப்படின்னு பாத்தீங்கன்னா we are going to check for odd parity. Odd parity இருந்தா skip, even parity இருந்தா increment பண்ணிட்டு store பண்ண போறோம். That's all. So the program logic will be like this. Kindly note down. So with this program we will stop today's lab session. LDA 8600H, ADI 00H, MAA, 00H, JPO. That means parity odd. If the accumulator, the last ALU result is having odd parity data, it must store the result directly, or else increment accumulator content and store it. That's all. So by even parity now 1 and 1 result, odd parity na 0 and 1 result. That's all. So quick type on the program mattum. So LDA we have to use. Then after that we have to type ADI. So here we have to go for dummy addition only. Okay. So after MBA instruction, JPO skip. Fine. The next instruction obviously it is INRA. Okay. So here we have skip instruction. Sorry, skip label பண்ணியாச்சு பண்ணதுக்கு அப்புறம் we have an STA instruction. Okay. So now I am loading the program. Okay, fine. The program got loaded successfully. Can you people type it in the chat? Any 8-bit data? I will say whether it is odd parity or even parity. Program la enna sollirukom parunga, even parity na namakku enna varanum? 01 for even parity, 00 for odd parity. Result enga irukanum parunga? Memory address we have to change. 8600 we have to load. Okay, so we have to change two things in the program. So the data is in 8600. Fine. The result must be stored in 9100. Fine. That's all. Now we are loading the program. Load address. Yes, Danya typed one data. அது போட்டு பார்க்கலாம். சிவகுமார் C3 சொல்லிருக்கீங்க. First Danya போட்டதை பார்த்துடலாம். F4, correct? What Danya it is? F4. So F4 is the data When you ask her to give, you will give it. I think device got disconnected. Sorry. Some connecting issue I'm having with the mobile phone. Wait a minute. I'll check it. Wait a minute. Sorry for the interruption. Okay, I think you people can see it now. Okay, the program is this one. Yes, I have loaded the program. So now I am going to give the data as so where I have to give the data 8600. 8600. So here I am going to give the data as what data Danya told is F4, correct? F4. So we'll give the data as F4. Okay, now we are going to run the program. So it's odd parity data, I think so. So in memory location 9100, we must get 00. Yes, we are getting 00. Okay, so now I can input the data as even parity. So I will give some data which must have even parity. Okay, I think, sorry, 8600. So we have to give the data in 8600. So instead of F4, I am going to give 93. Okay, it's a even parity data, I think so. I will type it in the chat. You will kindly think about it. The even parity data, correct? Even number of ones. So now I am going to run the program. So after I have run the program, I must get 01 in 9100. Yes, 01 in 9100. Fine, that's all. Okay. See, if anybody is having doubt, you can ask. Okay, now I'm going to stop the recording.